Hey guys, in today's session, I'm going to teach you Matplotlib and Seaborn. So, Matplotlib is a library in Python that enables users to generate visualization like histograms, scatter plots, bar chart, pie charts, and much more. Whereas Seaborn is a visualization library that is built on top of Matplotlib. It provides data visualization that are typically more aesthetic and statistically sophisticated. Okay, so let me start with Matplotlib first. So Matplotlib was developed on top of MATLAB, and we can get number of plots, whether whatever plots that are available in MATLAB is also available in Matplotlib. So Matplotlib is mainly used for basic plots like 2D, two-dimensional plots. So advanced plots like distribution and categorical plots can be plotted using Seaborn only. So based on Matplotlib, Seaborn was designed. There are a lot of features in Seaborn that are controlled by Matplotlib. So in Matplotlib, if you want to do plotting, it is comfortable with the NumPy array. When it comes to do plotting of a data frame, Seaborn is famous. Okay. So we will take two arrays and plot or see different functions using Matplotlib. Okay. So I'm going to first plot a pie chart using Matplotlib function. Let me first import the basic package for using Matplotlib. Let me first import Matplotlib. So pyplot is the functions that are available inside Matplotlib library. So I'm importing that. So let me first build a pie chart. So let me take two list, one list consisting of X. Wait. So let me take two lists. The first list consists of expense values, EXP values, and the second list consists of expense of labels. So in expense labels, we will have home rent, and some other variables are like food, next phone bill, next is car, and some other utilities. So in the expense values, we will have 1400, 1600, 600, 300, 410, and 250. Let's run this. Okay. Now we have imported matplotlib.pyplot. Let's use the pyplot function now to build a pie chart. So in PLT, in pyplot, we have plt dot py. Let's consider what are the value. Let's see the parameters that are available in py function. So the parameters that are available are like x. Let's consider x as our expense values. And well, let's see what are the other variables, the parameter, what are the other parameters that are present. So we will consider labels as expense labels. So let's pass expense labels as our labels. So let's run the code. Let me give labels is equal to expense label here. Okay, X is expense values and labels is expense labels. Okay, so let me run this code. You can see that we have plotted the expense value per for a particular expense labels. Okay, so let me use plt dot show attribute function. Okay, so we have plotted. So now what I'm going to do is, let me add the percentage of area, that is a percentage of amount that is acquired by home rent, food, phone bill, car, and other utilities. This can be done by passing an other parameter inside inside py function, that is auto PCT. Let's see what is auto PCT. So auto PCT is like a percentage, okay? When you are having a pie chart, so what are the percentage of values that you want to include in the pie diagram? So let me show you, and it also gives till what decimal value you want your percent value to be visible. Where is autopacity? So yeah, see, here is the autopacity. Autopacity is non or string or callable, and if not none, is a string or function used to label the wedges with their numerical values. The label will be placed inside the wedge. If it is a string format, the label will be in the format for percent PCT. So I will use percent PCT over here. If it is a function, it will be callable. Okay. So auto PCT is, let me take first, the format of auto PCT is include percent symbol, 2% symbol, and in between the 2% symbol, write point till what decimal you want the value. If you give 1F, so till one floating point, you will get the values. Let me put on this. Okay, what's the problem with this? Auto PCT. Incomplete format. Okay, let me see. Expense values labels is equal to expense labels. Auto PCT is 0.1F. Okay, it's 0.1F percent. Okay, yeah, you have to include between 2% symbol. You have to include what is the percentage, or till what floating percent you want. So this is like 0.1 floating percent value I want. So you are getting a value like for till one decimal. If you want till two decimal, you can write 0.2F over here. So now you can see you are getting values till two decimal points. So this radius is around 1 by default. The radius of this pie chart is around 1. Let's see how much. Radius is 1. So we can increase this radius by whatever value you want. Let's say the radius of this, you want it to be some 1.5. So we have increased the radius by 1.5. You can see this. The radius has been increased. So now let's use an explode function that is present inside the pie chart. So in pie chart, we have an explode function. Let's see what it gives. So here we have explode is equal to none. So explode array like default none. If not none is a length of x array which specifies the fraction of the radius with which the offset of each edge. So this is the edge, right? These are the edges that are attached, like utility edges, this and car edges, this and this. So you want this to move, how much offset you want from the pie diagram. So let me say I want zero offset for now. So initially the offset explode values are 0, 0, 0, 0. Explode is list of. So since we have 1, 2, 3, 4, 5 variables, we have to take 5 values inside. So now the offset is 0. Okay. So now the offset is 0. Let me do some offset. Let me perform some offset of 0.4, 0.04, and like 0.08. So what happens is that the 0.04 offset will happen to the higher majority area which is acquired by home rent. Okay, and the lower one is 0.08 is the utilities offset will be 0.08. So let me run this code. So you can see the explode function has made an offset from our diagram by 0.04. And for the utilities, other utilities, it has done 0.08. Let me increase this value by 0.1 and check how much explode it happen. See, like this, the explode function works. Let me go back to 0.05. Okay, this is how an explode function works. So now let's plot a scatter plot. This is all about pie chart. Building a pie chart using Matplotlib library. So let me plot a scatter plot. So let me take two list or array. You can take either of two, a list or an array. 1, 2, 3, 4, 5, 6, 7, 8. So let me take y values as 5, 2, 5, 7, 8, 4, 5. So let me plot scatter plot. So for plotting scatter plot, we have in Matplotlib, we have function called plt.scatter and plt.scatter of x comma y. So I have built the scatter plot here. There is some random scattering of data that is present over here. So now let me show you how we can. So the saving the data frame. So let's say you have created a data frame and you want to save that data frame. This is not the concept related to Matplotlib or Seaborn, but let me tell you how we can perform saving of data frame. Uh, for saving a data frame, you can go for import pandas as PD. Instead of saving a data frame, let me save this image. Okay, let me save this image. So we have this image here over here. So if you want to save this image into your local system, you can write a function like plt.save image, savefig of x comma y of scatter. So we have, let me give this uh, scatter.jpg. Okay, save plt.scatter of x comma y. Okay, let me save. Let me pass x is equal to plot plt.scatter and let me pass x over here. Let me see if this image gets saved. Okay, this is saying something. So path collection object has no attribute to write. Okay, so let's pass it plt.savefig. Let me pass scatter.jpg. Control C. So we have this diagram over here. Let me save this figure over here. Okay. So when you plot the diagram, you can save it using this function savefig. And I'm going to give the name of the file as scatter.jpg. Let me check if this saved. Let me see my local system. Let me run this. So refresh. Yeah, you can see here I have a scatter.jpg file that is created and this we have saved the figure. Okay, this is how you can save a figure after plotting. So now let me go to, this is some of the functions that you can perform using Matplotlib. So mostly we will be using Seaborn library while performing operations related to visualization. So mostly we will use Seaborn. So let me take Seaborn now, Seaborn library. Okay, so Seaborn is a package in Python which gives you advanced plotting capability in terms of visualization, and Seaborn is built on top of Matplotlib. So let me import Seaborn first. Import Seaborn as SNS. Let me run this. Let me take Let me load a Seaborn dataset. Let's see what are the Seaborn built-in dataset, Seaborn datasets that are available online. Seaborn datasets, GitHub. Okay, so Seaborn datasets, GitHub. Let me see. So we have a tips.csv file. So I'm going to import this file, tips.csv file from this. So let me import the Seaborn file. So tips is equal to sns.load dataset of file name is tips. Let me see the data frame. Okay, so we have imported the data frame over here. So these many rows are there. Okay, so let me now work with the data set that is available now in Seaborn. So we have 244 rows and 7 columns, and we have our column values as total bill, a column names as total bill, type, sex of a person, smoker, date, time, and size. So let me plot a relational plot between total bill and tip. How total bill is relating to tip. How a customer total bill is relating with the tip he is giving to the waiter. So let me write SNS dot relational plot. Relational plot is RELPLOT, relation plot of total X. See, well, let's see the parameters that are present inside relational plot. So we have X parameter and Y parameter, and we have a data over here. So let's give X as total bill, and let's pass Y variable as tip, how it is related, and let's pass the data that is TIPS. So you can see here how tip is related to the total bill. As you can see, as the total bill increases, the amount of tip to the waiter also increases. Okay. So you can see we have taken only two variables over here. So there is a third variable inside relational plot that's called hue. Let's see how hue works. So the relationship between x and y can be shown for different subsets of the data using the hue. Okay. So the relationship between x and y can be shown for different subsets. Let's say you have a total bill and the tip given by a customer. Let's say if you want to find which are all the customers that are smoker, like we have a smoker column like yes, no, this is a categorical variable. So we want to identify the customers who are all smokers from this plot. So you can give a third variable called hue. So this says the relation between x and y can be shown for different subset of data using the hue, size, and style parameter. These parameters controls what visual semantics are used to identify the different subsets. Basically, it's like we will plot first. Let's give who is equal to smoker. So when you see here, hue is a categorical and it is categorized based on a column. Okay, so now we have using categorical as a column smoker. So we can see for a person giving having a total bill and how much tips he is giving. You can see if person is smoker or not. This is the third variable that is helping us to identify if a person is smoker or not based on that x and y variables. So now let me plot a relational plot where we will use other variables also, like you can see here. So we have hue, the default. Let me check x y vectors. Hue. Okay, hue. So we had, let me check here, what are the variables that are present inside this? What are the parameters we have? So we have X, Y, hue, size, style, data. So let's pass size now, or let's pass size and style. So let's pass size, style to be time, style to be time. At what time of the day they usually come for dinner? Or let's pass style to be time first. Okay, at what time of the day they usually people visit the restaurant? So let me take this and let me pass style variable from this style parameter. The style parameter here is pardon, it's not a variable, it's a parameter. Style parameter is, let me take time. What time of the day the people usually visit for, people usually visit into the restaurant. So now you can see smoker is differentiated based on the color and time is differentiated based on a circle or cross mark. So if I take one variable over here, like let me take this point, you can see that the person is visiting during dinner time and his total bill comes out to be around 40 euros and he is giving a tip of around 7.6 euros and he is a non-smoker. Okay, he's not a smoker because it's in the orange part. This is how we are going to read the visualization. Let me consider some other plots. Let me consider the topmost plot. So this guy, this person is so we don't know the sex of the person. So let me consider this as this person, let me consider it as a person only. So this person is having a total bill of 50 and he is giving a total tip of 10 euros for the waiter, 10 for the waiter. And it comes out that he visits during dinner time and he is a smoker. So let's do something else. So now let me find out what sex is the person. Let me find out the sex of a person. So let me pass column as sex and see if a person is a male or not. So now you can see the highest point we considered over here comes out to be a male customer. Okay, so the customer is a male customer. So we are considering here it's a female customer. Female customer topmost bill comes out to be around 45 euros, and the highest tip the team female customer is giving is around 2 to 3, between 2 and 3, and she is coming for dinner and she is also no, she is a smoker. Okay, and here as I told you this person is a male now, and whatever I told you it is also eligible for this also. So this is how you do the visualization by looking at the graph. Now, so we have seen relational plot till now. So how relational plot can be used for plotting and how there are so many parameters that can be used to differentiate one column by other columns and how other columns are related. So you can see if I have to summarize this relational plot over here. So we have plotted relational plot with our x variable is total bill and y variable is tip, and we have taken the data, that is the tips data, which is a inbuilt data from our Seaborn, and in the Seaborn library we have hue to be a smoker, where hue is smoker is like a third variable which is differentiating tip and total bill, how if a person is a smoker or not. And we have style is equal to time, it differentiates how at what time during a day he is visiting the restaurant, if it's afternoon time or at the night time. And if the column equal to sex is telling if a person is a male or female. Now we have seen all things that are related to our relational plot. Now let's do categorical plot now. So we have in Seaborn, we have SNA cat plot function. It is used for category building of category to build a categorical plot. So let's see the parameters that are present here. So we have X, Y, and hue. Here also we have hue and we have data, row, column wrap. So many parameters are present inside the cat plot function. So let me pass X is equal to day and Y is equal to total bill. X as day, at what time they are the customers are visiting, and Y is equal to total bill is how much is the bill that's coming out during that time of the day. So data is tips. Okay? Data is tips is the data. So you can see the categorical plot that we have built here. Most of the customers usually visit on Thursday. So we have day is like we have Sunday, Saturday, Thursday, and Friday. Most of the customers visit usually on Sunday and Saturday, and very few people are visiting Friday, and somewhat better than Friday, people are visiting on Thursdays. So, but most are coming in weekends only. So now let me see. So we can see there is jitters. This is a jitter. Okay. Usually jitter is for true by default. Let's make jitter as false. Let's have a linear kind of thing, not linear, straight line kind of thing instead of like the data distributing like this. So let me pass jitter is equal to false. So you can see now there is no jitter. You can see clearly how data is distributed. These points over here it was telling how many customers are paying that total bill and how many customers visited that day. Now it's like a straight vertical line. Now let's do let's see other parameters that are present in the categorical plot. So I wanted to tell you about the kind attribute parameter that is here. By default, it's script. So let me see what are the other values that we can give for kind attribute. So in kind, we can the kind plot to draw corresponds to the name of the categorical axis level plotting function. Options are strip, swarm, box, violin, boxes, point, bar, or count. By default, it is strip. Let me plot a swarm plot now. Let's see how the swarm plot looks like. Let me ignore this jitter thing now. Let me pass kind is equal to swarm and run this. So you can see data is now, you can see how many customers are having a bill of around 20 euros. On Saturday, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 people are having a bill around 20 on Saturday and around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now almost around 10 people are having a bill around just less than 10, 20. And this is giving how many people are having that amount of bill on that particular day. So mostly data is distributed more over here between value 15 between value 10 and 30. As you can see on Thursdays, the data distribution is almost between value 10 and 20, and in Friday it is almost between 8 and 15, and in on Saturday the value distribution is mostly around between 10 and 30, and also on Sundays it's almost between 10 and 30 35 kind of thing. So now we have built swarm plot. So let's see violin plot now. So let me pass a violin over here. Kind is equal to violin. So we have other plot that can be plotted where violin, box, and some other plots. Let me see. So kind is we have seen swarm plot. Let me plot violin plot now. So violin plot gives the distribution, how data is distributed. Now you can see most of the data as it is between values distributed between 5 and 30. Here between 5 and 30. Here also between 5 and 20. Here 5 and 20, 20, just above 20 here. So here the values between more than 0 and less than 30, more than 0 and less than 30 are the value distribution. And also you can see some points over here, white colored dots over here. This is nothing but a median. This is the median value it is giving. Here you can see it is giving the median value, how the total bill comes out, what is the median of the total bill. Let me now plot a blocks plot. So box plot is one of the plots that is mostly used for finding out outliers in your data set. If there is any outliers present in your data set, it can be found out easily using box plot. And we will do some manipulation task to remove the outliers from our data set uh, by using IQR method. It's an interquartile range. IQR is an interquartile range. Let me plot box plot for now. So you can see here on there are some outliers. These are the outliers. These values that are coming outside. So these are called outliers. This is the minimum value. This is the minimum bill that is being generated on that day, and these are the maximum bill that is generated. But still there are outliers over there considering. So this is considered as Q1 and this is Q5. So here is the IQR. Interquartile range is this blue color region is the interquartile range. Okay. This yellow color region is IQR. This green color region is IQR on Saturday, and this red color region is IQR interquartile range. And between interquartile lines, we have a horizontal line that is present. This is the median. That is the 50% of the value. 50% value lies over here. The 50th percent value. So this is mean median, and so we will learn more about box plot in the coming classes during our statistic classes. And this is the Q1 value, this is Q2 value, Q3 as our median, Q4 is the 75th percentile, and Q5 is our maximum value, and these are outliers. We will discuss how to deal with outliers in the statistic class. So let me plot now this plot. This plot is nothing but a distribution plot. So now let me plot SN. We have in SNS we have this plot, PLOT. In this plot we have what are the parameters? Let me check. So the parameters that are present is A is none, bins is none. So KDE, and we have hist. Hist is histogram is true or false. So here let me see, hist is true. Okay, let me pass. Where is, let me pass A is, let me pass X is equal to tips, sorry, tips of total, total bill. Let me plot the now histogram for this, or if you want, this is normal distribution curve. If you don't want the histogram plot from this, you can make hist is equal to false, because in the parameters if you see hist is given to be true, so let's make hist is equal to false from this. So now we can see the distribution of data, total bill, how the total bill is distributed, how it comes out, that it tells you the density. So you can see some warnings over here. So if you want this warnings to go out, you can do just import warnings. You can do here import warnings. So do import warnings. write import warnings library, and write warnings dot. So let me see, import warnings Python. So how we can ignore? So warnings dot. Let me check it in Stack Overflow. Ignore warnings documentation. Let me check. Ignore warnings. Python. Let me pass Stack Overflow instead. Okay, we have simple filter. Okay, we have ignore warnings dot simple filter. So let me copy this code and let me paste this over here. So we have in warnings dot simple filter. We are trying to ignore the warnings which are user warnings. Let me run this code, and now let me run this code. Okay, so still it's showing. Okay, so ignore it. I will show you in another class. So now let me take a joint plot. Now let me so this is all about normal distribution of data, and how data how we plot this plot, distribution plot. Now let me show you about joint plot. So we have joint plot SNS dot joint plot, where we have the parameters x as, let me pass x is to be total bill here. Do we have another parameter? Let me check. Yeah, we have another parameter. Let's see if we have to pass x is y data is okay. Let me pass only total bill. X is total bill. Y is tips. Data is y is tip. Data is IPS. So we have plotted the joint plot. This is similar to the relational plot, that this thing is similar to the relational plot, and this is like a histogram distribution plot, how data distribution has occurred. You can see more data lies in this region, so total bill, more data is over. Normal distribution is like this, and similarly for the tip, more distribution is towards between 5, between 0 and between 0 and around 6. So this is the distribution of tips on the right hand side that is shown here. This is joint plot, which is giving both histogram plot as well as the relational plot. Now let me show you another data frame. Let me show you another, let me load another data set. So we have already imported as Seaborn and SNS. So let me load another data set called as flower. So let's load data set of iris. Let's import iris data set. Let's see what are the data that's present. So in iris data set, we have sepal length, sepal width, petal width, and species. We have around 50 rows and 5 columns. Now let me draw a pair plot for this. Pair plot is like a correlation plot. It's like how one variable uh, one variable changes according to the another variable. So let me plot SNS dot pair plot, pair plot of flower data set. Okay, so this is how a pair plot has visualized. I mean, this is how we can create a pair plot. So now you can see this is sepal length versus sepal length. X sepal length, Y is also sepal length. That's why because of that we are getting an histogram kind of plot here. Otherwise, you can see we are getting a pair plot, a relational plot. These are relational plot kind of thing. How data is distributed. So this is all about the class regarding Matplotlib and Seaborn. So if you guys want to study a case study on Matplotlib and Seaborn, I'm going to upload that lecture as well. Hope you enjoyed the session. Thank you, and please like, share, and subscribe the channel.